Hi there, and welcome to today's class. For today, we're discussing about a very important topic in physics known as wave. Let's discuss wave. Let's discuss, or perhaps let's define wave, and let's discuss about the classification of wave and also the description of wave. And finally, we'll look at the equation of wave motion. All right, let's discuss about wave. What's wave by definition? A wave is simply a disturbance that travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. So I'm saying that a wave is simply a disturbance that travels through a medium, transferring energy from one point to another without causing a permanent displacement of the wave. All right, having defined wave, let's look at something very important. Something important. Let's look into classification of wave. Wave can be classified in two categories. Number one is that wave can be classified based on medium of propagation. Number two, wave can be classified based on direction of travel. These are the two classification of wave. So wave can be classified based on medium of propagation. Wave can be classified based on direction of travel. Let's discuss this concept one after the other. When we say based on medium of propagation, what do we mean? Number one, all right, let's discuss the first one, based on medium of propagation. When it comes to based on medium of propagation, there are about two types of wave there. So we have number one there, let me call it I. We have the mechanical wave. Number two there, II. We have the electromagnetic wave. So when it comes to based on medium of propagation, there are about two type of wave there. We have the mechanical wave and electromagnetic wave. Let's define this one after the other. What a mechanical wave? Definition: a mechanical wave is simply a wave that requires a material medium for its propagation. So a mechanical wave is simply a wave that requires a material medium for its propagation. Example of mechanical wave includes sound wave, water wave, wave on a rope or spring. These are the examples of mechanical wave. All right, let's discuss second one there called electromagnetic wave. Definition: electromagnetic wave is simply a wave that does not require a material medium for its propagation. Example of electromagnetic wave are X-ray, gamma ray, radio wave, light wave, and etc. These are the examples of electromagnetic wave. So get this right. Get this right. When it comes to based on medium of propagation, there are two waves there: the magnetic wave and electromagnetic wave. When it comes to mechanical wave, perhaps we have mechanical wave and electromagnetic wave. When it comes to mechanical wave, it's simply a wave that requires a material medium for its propagation. This one here does not require a material medium, please. It requires a material medium, does not require a material medium. Those are the key concepts you need to note when you're defining the two. All right, I haven't discussed about the concept behind classification of wave based on medium of propagation. Let's discuss second type of classification of wave, known as based on direction of travel. Let's discuss about the second classification of wave based on direction of travel. When it comes to based on direction of travel, there are about two types of wave here too. The first one there is called transverse wave. The second one there is called longitudinal wave. Let's discuss these two types of wave one after the other. What is transverse wave? Definition. Let's start with number one there. Transverse wave. Definition. A transverse wave is simply a wave that travels in the direction perpendicular to the direction of the vibration or disturbance caused by the wave, right? So when it comes to transverse wave, transverse wave is simply a wave that travels in the direction perpendicular, please, very important, perpendicular in quotes, perpendicular to the direction of the vibration or disturbance causing the wave. That's like definition for transverse wave. Example of transverse wave are simply water wave, light wave, and radio wave. Those are the examples of transverse wave, please. All right, let's discuss second concept there called longitudinal wave. All right, definition, please. Longitudinal wave is simply a wave that travels in a direction parallel to the direction of the vibration or disturbance causing the causing the wave. Now, note two things. When it comes to transverse wave, the wave is traveling what? Perpendicular to the direction of the vibration. When it comes to longitudinal wave, it is traveling what? Parallel to the direction of what? The disturbance or vibration causing the wave. So note for concept. When it comes to mechanical wave, it requires a material medium. Electromagnetic wave does not require a material medium. Transverse wave travels perpendicular. Longitudinal wave travels parallel. That's the concept. If you can understand those four concepts I just mentioned out, you can actually not define them without cramming them. That's the concept. Understand them. You don't need to cram. Understand them. That's all. All right. I want to discuss about the classification of wave and the categories. Let's discuss something important. All right. Example of longitudinal wave are simply sound wave, microphone wave, tsunami, and wave, and etc. Right? That's the example for longitudinal wave. All right. Let's discuss something important. Description of wave motion. All right, let's discuss about description of wave motion. So, all right, wave motion. Something to note is that when it comes to describing a wave motion, or perhaps a wave can be described as a sine wave, or call it graph wave, or wave motion. I'll draw a diagram. So this is like diagram of a wave. This diagram to illustrate wave motion, right? So this is how a wave motion look like. So I have something of this nature, right? So call here crest, 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 trough, trough, amplitude, right? All right, okay. Wavelength, here to have wavelength lambda, right? So this is like how a wave travels. So this is like description of wave, as you can see in front of you. All right, I haven't draw out this. Let's discuss about some important concept using using describing wave motion. All right, one line space paragraph. Some important concepts used in describing a wave motion. Number one, amplitude. Number one, amplitude. That's a definition. Amplitude is simply the maximum vertical displacement covered by a wave particle from its point of rest. That's like definition for amplitude. It is represented by capital letter A, and it is measured in meters. Measured in meters. That's definition for amplitude. Let's discuss second concept when it comes to describing wave motion. That's wavelength. Let's discuss wavelength. A Greek symbol called lambda. Wavelength definition: a wavelength is simply a distance between, observe, between two successive crests or two successive troughs in a wave particle, or perhaps in a wave motion if you want to. It's represented by a Greek symbol called lambda. This is a Greek symbol called lambda. Right? It is measured. It is also it's important to note that it is measured in meters. It is measured in meters. Those are like the concepts behind describing a wave motion. Let's discuss the third one, number 3. Some concepts required in describing wave motion. Number 1, amplitude. Number 2, wavelength. Number 3, there, frequency. Frequency, that's F. Definition: frequency is simply the number of complete vibration or cycle a wave particle make in 1 second. That's like definition for frequency. It is measured in hertz. All right, I'm saying that frequency is measured in what? Hertz. Hertz. This is symbolic representation of the SI unit for frequency, right? So the number of complete vibration or cycle covered by a wave particle just in a second is said to be what? Frequency. Let us call this third concept, or perhaps the fourth concept, called period. Capital T. Definition: A period is simply the number of time it takes a wave particle to complete one oscillation. So the number of time it takes a wave particle to complete one oscillation is said to be what? Period. So period is measured in second x second. Note at this point here, note that the relationship between frequency and period, or perhaps, all right, note that the relationship between frequency and period is given below. There, it means that frequency is equal to 1 over period, or period is equal to 1 over frequency. This is like the mathematical relationship expression between frequency and wave, that the frequency of a wave is equal in value to what? The inverse of what? Period. Or the period of a wave is inversely equal to the inverse of the frequency of a wave particle. All right, the fifth one there is called frequency period. We have what we called wave speed, or perhaps wave velocity. Wave speed definition. Wave speed represented by with V. Definition: a wave speed is simply known as wave velocity. It is simply the distance, or perhaps the displacement traveled by a wave particle per second. I'm saying that wave speed, also called wave velocity, is simply the displacement traveled by a wave particle per second. It's represented by V. It is measured in meter per second. It is measured in meter per second. All right, at this point here, note one thing very important. Note at this point here, note one thing very important. Note that the wave speed of a wave motion, the frequency and wavelength are connected by the equation V is equal to F lambda. This is a very important equation when it comes to describing wave motion, that the wave speed is equal to the product of the frequency and the wavelength of a wave motion. This is a very, very important equation you need to note when it comes to describing wave motion. All right, where V is called wave speed, where F there is called frequency, and this is called wavelength, also called lambda, right? All right, let's discuss one last thing before we start solving several past questions based on JAMB, WAEC, and what have you. Let's discuss one thing very important: equation of a wave. Let's discuss the equation of a wave. The equation of a wave is given below. That's y is equal to a sine into 2 pi x over lambda minus 2 pi ft. This is simply the equation of wave motion. 2 pi x all over lambda minus 2 pi ft. All right, this is the equation of wave, right? Very, very important. Please know this formula, right? Very, very important. Let's find something where A is called what? The amplitude in meters, measured in meters, where x is called the horizontal displacement measured in meters. What again there? We have lambda called wave length, also measured in meters. F, that's frequency, as we established. Frequency, that's hertz, hz. T is simply the time it takes a wave particle, right? Is that all? A, x, lambda, frequency, and time. We know pi is 20/7, right? So this is like the definition of each parameter. All right, let's use all this idea to solve JAMB and WAEC past questions and see what we can do using all these concepts. All right, let's use all this idea we have actually learned from wave to solve JAMB and WAEC past question. Question 1 says, a plane progressive wave is represented by the equation y is equal to 2 sine into 2000 pi t minus 0.5 x. So a plane progressive wave is represented by the equation, this one here, where the symbol have their usual meaning. Now the question says, what is the frequency of the wave? Question I. Frequency, that's f, of the wave. I. What is the amplitude? Amplitude, that's A, of the wave. Let's try to solve this question here. So in this question here, I'm looking for two things. What and what? Frequency and amplitude. And I'm given the equation to be this. Y is equal to 2 sine 2000 pi t minus 0.5 x. Now look up, please. First things first, your first task is to recall your general wave equation, which will say that y is equal to a sine into 2 pi x over lambda minus 2 pi ft. This is our general formula for wave, right? As we said earlier. So now there's two things you need to watch out for. Watch out for t and x, please. Very important. Know that you need to watch out for your t and x. So look up, please. My first question says, look up, please. Oh, and after you know how to check out for your t and x, your next task is to compare. You're comparing. That's all. All right. This is a given equation here from the question. This is my real equation for wave. So I'm comparing the two together. That's the concept. So the first question says, find the frequency, right? So I'm looking for the frequency. Now look up, please. From my original wave equation, please. If I'm in between t and x, in between t equation and s equation, if I'm looking for frequency, which one will I pick? Of course, I'll pick the one of t because t has f frequency in it. So I'm going to compare this one here that has t with this one that has t. Please listen. I'm looking for frequency. I see that watch out for two things, x and t. X and t, very important. Now I'm looking for frequency. Frequency occur, is it in s equation or t equation? Of course, t. F occur in what? T equation. So I'm going to compare this t equation. I'm going to compare the wave original equation, which is having t, with a given equation which is having t. So it means that I'm saying that I'll be having solution. First is first, I'll be having 2 pi ft to be equal to what? 2000 pi t. That's the concept. I'm going to equate them. This means that, of course, I'm looking for f. So divide through by 2 pi t. So divide by 2 pi t to get f. So I'll have that 2 pi ft over 2 pi t is equal to 2000 pi t over 2 pi t. This one here cancelled out this and this, left with f. So f now is equal to 2 here 1, 2 here is what? 1000, right? So this one cancel out this, and what was 1000? So that becomes 1000 what? The hz as the symbolic representation of frequency. Or perhaps you can say that frequency is equal to 10 to the power 3 hz, right? Hz. This is like the answer for finding frequency. So let's get the second one, the amplitude. Let's calculate for amplitude. So the concept here is to compare. I just said that earlier, compare. Now I'm looking for amplitude. For my wave general equation, my amplitude is here, A. Now compare it with the given equation. This is A, position of A here. This is my position of A here. So it means that my amplitude here is 2. So therefore, amplitude, which is A, is equal to 2 meters. Please, very important, 2 meters. All right, so that's the first question here, and this is how you solve it, right? Check out for your t and x. I'll check out for your t and x. Anything I told to look for, check it out for your s and t if it's a standard scuff. All right, example 2. Let's try to take this question, this JAMB question. The question says, given the progressive wave equation, example 2, given a progressive wave equation, y is equal to 5 sine into 2000 pi t minus 0.4x. Given the progressive wave equation, that this is the wave equation here, calculate the wavelength. That's all. All right, calculate the what? Wavelength. So number 1 there, I'm looking for what? Wave length. That's lambda. How do I get my wavelength? We said when it comes to getting wavelength, perhaps, yes, your first task is to what? Check out for two things, t and x. Now I'm looking for wavelength. I'm looking for wavelength from my original wave equation. In between x and t, which equation among s and t has wavelength? Of course, x. S contain wavelength. So it means that I'll be comparing the equation of x with the equation of x here too. So I'm having equation of x here compared with this one. So it means that I'll be having 2 pi x over lambda to be equal to what? Is 0.4x. Please don't put negative, please. Ignore the negative. It's just trying to tell you that the wave is actually facing the negative side. So negative side, right? Don't consider the negative. Observe that I didn't consider the negative when I was solving this one here, right? So don't consider negative, please. All right, I'm going to compare these two together. If this is true, in mathematics, there's something important in mathematics you need to note, is that if I have same value both in the left hand side and the right hand side of the equation, they can cancel out. So this x here can cancel out this x here, mathematically correct. So I'll be having 2 pi all over lambda to be equal to 0.4. Multiply lambda by 0.4, I'll have 2 pi to be equal to 0.4 lambda. And my task now is to get what? Make lambda subject, right? If I make lambda subject there, divide by 0.4, divide by 0.4. This means that this cancel out this. So I'm left with what? Lambda to be equal to 2 pi over 0.4. Give me value. All right. If I divide pi, 2 times 22, 2 times 3.142 as pi, divided by 0.4, I'll have 15.7. I have 15.7 meter there. So my answer there becomes 15.7 meters. All right, so this is how to solve this JAMB question. All right, let's take other example. The example here says, example 3 says, the distance between two successive crests of a wave is 15 centimeter and the velocity is 30 meter per second. Calculate the frequency. That's all. All right, solution. First things first, your first task is to list out the given parameter, the distance between two successive crests of a wave. So that's what wavelength, as we discussed earlier. The distance between two successive crests or trough is wavelength. So I'm given that to be 15 centimeter. So wavelength, that's lambda, 15 centimeter. All right, and the velocity is 300 meter per second. So velocity, that's wave speed per se. Wave speed, that's v, 300 meter per second. The question now says calculate the frequency. That's the frequency, which is y, is unknown. All right, there is a equation. There is simply a equation that relates these 3 parameters together. So there's a connection between these 3 parameters. All right, before that, observe that I'm having velocity, wave speed per se as meter per second. This is its original unit, but I'm having meter. This is centimeter. I need to convert the centimeter to meter. So divide this by what? By 100. I'll have 0.15 meter. After converting your centimeter to meter, which is 0.5 meter, what's the next task? Recall that we said V is equal to F lambda, right? In our just recently we just discussed about frequency, wavelength, and lambda. I told you that there's an equation that connects them, which is this. So it means that I'm looking for what the frequency, make F subject, divide by lambda, this cancel out this, left with that F is equal to V over lambda. What's V? That's 300 all over lambda is what? The 0.15. If I divide these two, I'll be having that frequency is equal to 2000 Hz, right? That's SI for frequency. Or perhaps I can choose to say 2 times 10 to the power 3 Hz. All right, that's how to solve this question here. Question A says 4.5 times 10 to the power 5. Option B says 2.0 times 10 to the power 3. C, 4.5 times 10 to the power 2. D, 2.0. Of course, my answer there is what? Option B. My answer there is option B. All right, let's take example 4. Example 4 says a wave that travel through a stretched screen is known as dash. A. Electromagnetic wave. B. Microwave. C. Mechanical wave. Which is the answer? Of course, I thought when we were discussing about mechanical wave, I said mechanical wave. The example of mechanical wave are simply water wave. We say mechanical wave are wave that does not require that requires a material medium, please, for its propagation. If that is true, I said the examples are simply, check your notes. The examples are simply what? Water wave, sound wave, wave on a rope or string. So I'm here now. I'm hearing that a wave that travels through a stress string is known as what? That's what the mechanical wave. That's the answer to that question there. All right, example. Let's just talk on that past question. The question here says, let's take one more question here and let's see how we can solve this. All right, example. I think this should be 4. Example 4. Oh, sorry, 5 per se. Example 5. The equation of the wave traveling in a horizontal direction is expressed as y to be equal to 15 sine 2 over 5 into 60t minus x. All right, what is the wavelength? What is the wavelength? Wavelength. What is the wavelength? That's lambda. So option A is given to be 60 meter. Option B, 5 meter. Option C, 15 meter. Option D, I have 2 meters. Let's get this done. First things first, look up, please. Listen. Look at this equation here. This equation is somehow confusing. Why did I say that? My general wave equation is given to be A sine. After A sine, there's nothing here. Observe that I'm having, let's say this is 15, this is A sine. I'm having something here. So this one now, as it has bring a confusion. So for something of this nature, what do you do first? Your first task, you can't just compare directly. First task is to expand the equation. Solution. If I expand this one, I'll have that y is equal to 15 sine 2 over 5 times 60. That will give 120 t over 5. That's the first task. You expand through 2 over 5 times minus x. That becomes minus 2x over 5. This is the first task here. You expand through using this number in front of the bracket. When you are done expanding, what next? Compare. I'm looking for what? Wavelength. That's lambda. Between x and t, which one has lambda? That's x. So I'm comparing the what? Both x equation. These two x equation, I'm comparing them together. So I'm having 2 pi x over lambda. 2 pi x over lambda is equal to what? 2x over 5. I am saying something that if we have the same value, or perhaps the same alphabet in both left hand side and right hand side of the equation, they can cancel out. So s cancel out x here, 2 cancel out 2 here. So I'll be left with what? Pi over lambda is equal to what? 1 over 5. If I multiply this through, I'll be having that 1 times lambda will give lambda to be equal to pi times 5 will give 5 pi. Multiply the 2. Lambda is equal to I'll have 15.71 meters. Of course, from this option I'm seeing here, option C is my answer. Option C is my answer. But if I approximate this one here, will give me 16. But we assume that since I'm seeing this kind of option here, then option C should be my answer. Alright, so this is how to solve several WAEC and JAMB questions based on WAVE. If you found this class helpful, do well to share to your friends and classmates, and like and leave a constructive comment in the comment section below, and ask your question. I'll answer you, or perhaps I'll reply you as fast as I can. You can also reach out by joining our WhatsApp group, which I'll leave the link in the description of this video. So check the description of this video. I'll leave a link to our WhatsApp group, so where you can actually reach us and tell us which content you want video on, or perhaps which topic you want video on. See you in our next class.